Hey guys, Mr. Parkins here. So as promised, this is going to be a little bit of help with your logo project. And a lot of you have this, not everybody does, but if you do, this could help you out. So what we're dealing with here is portions of a conic section. So basically this is if you have a circle, but you only have that much of it. Just a quarter circle maybe. Okay, maybe we're dealing with an ellipse, and you just have the top half. The trickiest one is probably if you have a hyperbola, so I'll draw the whole thing here, but you're just using a portion of it, so I would erase that entire left side and maybe just the bottom half of that one. Alright, so just going to show you one example here that hopefully helps out, and we'll take a look at it. Okay, so let's check out the example that I have here. First of all, forgive me for my drawing. I don't have my stylus with me, so I'm trying to do this with just my finger on the screen, and it's clearly not quite as good as the other one, so just bear with me on it. So what we're looking at here is a portion of an ellipse graphed in black, and then we have a line cutting through it, and I've already written out both equations. I'm sure everybody is fine with writing out what these equations are. So if you look at the ellipse, what we basically have is you have the entire top half of it, but you don't have all of the bottom. Okay, so you have the entire top that I've outlined right there is fine, but then where we're going to run into a little bit of trouble is on this bottom half. Okay, right there. So what we're going to have to do is take this equation over here, which is our ellipse equation, and we're going to have to solve for y and deal with everything from that point. Okay, so let's do that. So here's our ellipse equation, and again what we want to do is get the y completely by itself. Okay, so first we're going to take this term here and just subtract it over to the other side. So on the left that would leave us with y minus 6 squared over 1 equals 1 minus that entire term there, x minus 5 squared over 4. Okay. Now we're lucky here that the denominator is just a 1. Normally we would have to multiply that to the other side, but in this case it's just multiplying by 1, so nothing's going to be affected. So the next step is to square root both sides of the equation. And don't forget, when we square root, we get the plus or minus. That's what's going to give us the top half and bottom half of the ellipse that we're dealing with here. Okay, so what we end up with on the left side is y minus 6 equals plus or minus, really just copying what you see right there, 1 minus x minus 5. Wow, that's gross. Sorry about that. Okay, and then the last step would be to take this take this minus 6 and add it over to the right side. And now you always want to put that out front of the plus or minus. So the final equation would look like y equals 6 plus or minus the square root of 1 minus x minus 5 squared over 4. Okay, so that's what the equation comes out to be. Now it's very important that you understand that this is two separate equations, and if we were going to graph them in a calculator, we would go like this. We would say y1 equals 6 plus the square root of 1 minus x minus 5 squared over 4. And then in y2 we would do 6 minus. Okay, we've definitely seen this before, but just trying to give a little review here. Okay. By the way, you're going to have to be able to do this on your test next week anyway, so this is good for everybody to know. Alright, so what this, again, we've talked about this too, but what this gives you, this is the top half of the ellipse, and this here is the bottom half. Okay, so if we go back real quick to the second slide, we want the entire top half. So I'm basically going to include that equation in the whole thing, but the bottom half is what's going to get restricted. Okay, now we do want, if I just continue this here and continue drawing that ellipse like that, the bottom half is going to be basically that red part that's highlighted is the only thing that we want to deal with. So I have to restrict it and say those are the only x values that I want. Alright, now if it's a nice whole number, like let's pretend that it come all the way over to 5 here. If it was right on that point, we would say I want the values between 5 and 7. Okay, so that would look something like this. X is between 5 and 7 for the bottom half. Okay, pretty simple. But what you got to do here is something that I'm going to extend just a little bit further. Okay, so the key point on this one is what you would need to find is the intersection point between the ellipse and the line that's drawn. So I'm just going to highlight it really dark here, if I can do that. Okay, that spot right there is basically the intersection point of the ellipse and the line. Okay, so what you would do is you would go into y equals now, and you would take the second equation that we just had in y2. If I hop back here, so this guy down here, this y2 equation, that's the one that's going to be affected, right? So what we want to do is take that equation. Okay, we can pretty much forget about the whole original. Alright, and what we would have is this equation in y2. We would want that graphed in the calculator along with this equation here, which was the line. Alright, and in the calculator what you would have is you would look for the intersection point. Okay, so that's going to look something like this. Again, I'm just going to go really rough sketch right now, but it's going to look like, okay, we know that line is going to come through like this, and then the bottom half of the ellipse is what we would have graphed, so it would look like that. Okay, and we would want to be finding this point right here by doing second trace intersect. Okay, so hopefully that makes a little bit of sense to you. I'm going to stop there and have the video nice and short. I'll see you guys soon. Good luck on the logo project.